Bam! Mr. True. In this video, we're going to do two examples of writing the equation, creating the equation of a line given a point and the equation of another line. We're going to write the equation of a line which is parallel to the given line, and we're going to write the equation of a line which is perpendicular to a given line. Now, whether you're in Algebra 1, Pre-Algebra, Algebra 2, Pre-Calc, even in Calculus, I will still, at some point, especially for those questions that seem a bit more difficult at first, what is the core? What is the minimum information you need to write the equation of a line? You need a point and a slope. That's it. No matter what the problem looks like, maybe they give you 2 points, maybe they give you a point and a y-intercept or a point and a slope, in this case a coordinate and the equation of another line, or even if you're doing calculus and doing derivatives, it comes down to write the equation of a line, you need a point and a slope. Regardless of what information is given to you, that's what you need to pull out of it. So what is point-slope form of a line? Well, that point-slope form of a line is y minus y sub 1 is equal to m times, not equals, m times x minus x sub 1. And the only place in this equation where you're going to plug in numbers as you create this equation of a line is at the location of y sub 1, that's going to look just almost like the yellow, y sub 1, m, and x sub 1. This other x and y, these x variables, x and y, that don't have a subscript, those are going to represent and allow you to find the location of all of the points on the line that you so desire. But to write the equation of a line, y minus y sub 1 is equal to m times x minus x sub 1. If you forget this point-slope form of a line, most of my students will remember more consistently, because we use it so often, the slope formula. The slope formula is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The point-slope form of a line is just a manipulated version, a variation of the slope formula. If I undo that division with multiplication, and I multiply both sides of this equation by x sub 2 minus x sub 1 over on the right-hand side, and x sub 2 minus x sub 1 on the left-hand side, that multiplication of x sub 2 minus x sub 1 is going to cancel on the right-hand side the division of x sub 2 minus x sub 1. And here you go. We have y sub 2 minus y sub 1 on one side of the equal sign. Down here I have it on the left. And on the right-hand side we have the slope of m times x sub 2 minus x sub 1. But we need to leave some room in our equation for a unknown variable of x and y, which describes all of the points along the line. We just need one point, x sub 1 and y sub 1, a location in space that we can then follow the directions of slope to create and go along with that line. So for example number 1, we have a point given of 4, 1, which means that for example 1, again, we have 4, 1 representing a variable, a location, a horizontal location of x equals 4, and a vertical location of this fixed point, a y-coordinate of 1. So in our equation of y minus y sub 1 is equal to m times x minus x sub 1, this is how much we have already. We have y minus our y-coordinate of the point, which is 1, is equal to, now we haven't worked out the slope yet, but we do have x minus our fixed point, our fixed location initial coordinate is equal to 4. What we need to do is figure out what the slope is. And that is the only reason and the only information that we are going to care or need to pull out of the equation of that line 4x minus 2y is equal to 3. Now, this equation right now is in the form of what we would call standard form, where we have coefficients which are integers in front of x and y, and it's equal to a constant. We want to bring this equation 4x minus 2y is equal to 3. There's multiple ways to pull the slope of the line, get that information out of this equation, but I think the easiest thing to do is to convert this equation of a line in standard form into the format of the slope-intercept form. which is y is equal to mx plus b, where we can see the slope in front of the variable of x and the y-intercept being that constant that's after the, well, it could be plus or minus, but it's going to be after the term which contains the variable of x. So if we solve this equation for y by first isolating both sides or moving the 4x from the left-hand side to the right-hand side using subtraction, and then dividing by -2 to undo the multiplication. That's the method that's connecting the -2 to the y. And we have this now equation 4x minus 2y is equal to 3 in slope-intercept form of y is equal to 2x minus 3 over 2. Once that y is solved for, and on the left-hand side of the equal sign all by itself, the coefficient of x is going to be that slope. So the slope of our given line is, and I'm going to put it over here, is equal to, the parallel slope is going to be equal to, well, 2. But slope is effectively rise over run. When you look at the slope of a line, you should be seeing two numbers, not just one. You want to know from a fixed point, in this case 4, 1, how are we moving? We're going to rise 2 and then run over 1. That's going to be used for the equation of the line which is parallel to the given line. For the perpendicular slope, perpendicular slopes are opposite reciprocals. The opposite part of that two-word phrase means to change the sign. The parallel slope, the slope of the given line is equal to positive 2 over 1, so change that positive to negative, and then do the reciprocal of 2 over 1, which means to flip that fraction. The perpendicular slope is going to be negative 1/2. And we're going to find the equation of the parallel line first. So that means we're going to use the slope of 2. Whoops, chalk down. So we have y minus 1 is equal to 2 times x minus 4. The equation of this line is going to pass through the point, the given point of 4, 1, and it will be parallel to our given equation of 4x minus 2y. Now note, as soon as I converted that equation into slope-intercept form, I pulled out the slope, and that's all I'm using. I'm not using the y-intercept of -3/2 or anything else for that matter. We are just given the equation of that line to use its slope. This is in point slope form. It's a good chance that your teacher will be asking for this equation, or you may want to have this equation in slope-intercept form, y equals mx plus b, to make it easier to graph. So if you want to do that, if you need to do that, we're going to multiply 2 through the parentheses, giving us y minus 1 is equal to 2x minus 8, and then add both sides by 1, and get y is equal to 2x minus 7. Great. Now, coming back here, we have y minus y sub 1 is equal to m times x minus x sub 1, rewriting that point slope form of the equation of a line, because maybe I'm still trying to memorize that equation, so the more times I'm writing it in my practice and my homework, the sooner I'm going to have that memorized. I'm writing it down, I'm not just saying it and listening to it and reading it. Again, we have y minus, the y-coordinate of our given point is 1, but now we're just going to plug in a slope of -1/2 for that perpendicular slope, and x minus the x-coordinate of the given point, which of course, once again, is going to be 4. Dealing with this fraction, as I think about multiplying -1/2 through the parentheses, I'm going to have -1/2 times 1, which is just going to be -1/2, and we have -1/2 times 4. Well, -4. Well, 1/2 of 4 is going to come out to be 2, which will be an integer. And you should be good working with and practicing with fractions, but there is always those students that really just are terrified of them, or they just really do not like working with fractions. If you're one of those students, instead of distributing the fraction of -1/2, which is what I would do, you could get rid of that fraction, get rid of that division by applying an inverse math operation, which is to say recognize that the denominator, recognize that below that fraction bar you have a factor of 2, a division basically of 2. You can undo that division of 2 by multiplying by 2. We can multiply both the left and the right hand side of this equation by 2, and it'll add a little bit of a few steps to our work, but for some students that may be worth it. On the left hand side we have 2y as we distribute minus 2, and on the right hand side you have parentheses locking this these two terms together of x minus 4, and it's acting as a single factor. So when you have this multiplication of 2, it's 2 times one term or one factor, so hopefully when you see that 2 over 1 on the right hand side getting multiplied by negative 1 over 2, you can see that that multiplication of 2 is going to cancel out the division of 2, and on the left hand side we haven't done anything to get rid of the negative, so we have negative 1 parentheses x minus 4. So we're going to then distribute the negative 1 through the parentheses, giving us 2y minus 2 is equal to negative x plus 4. On the left hand side we have that variable of y. We're trying to isolate that. We want to undo the subtraction of 2 by adding both sides by 2. And by getting rid of that fraction, I've added a couple lines of work to my work and now making me run out of space, but that's okay. We'll have this 2y is equal to negative x plus 6, and just bring this up here. In our last step, isolate the y by undoing the multiplication of 2 by dividing every term in the equation, giving us finally y is equal to negative 1/2 x plus 3. Now, to make sure I haven't made any mistakes, there's a couple of things I could do. First of all, go back and check my algebra for finding the slope of the original line, 4x, the given line of 4x minus 2y is equal to 3. I started off with that slope of negative 1/2. I did a little bit of getting rid of that fraction, so maybe just to make sure I didn't do something silly, I'm looking at my final equation in slope-intercept form, and I still have that coefficient of negative 1/2 in front of the x after I've isolated the y, so I still have that slope of negative 1/2. And another thing you could do, you could, with the y equals mx plus b format, you could graph the two answers that we got, and making sure that they pass through 4-1 if you're really careful using straight edges and graph paper with your work. But that is our first example. Now you probably are asking, why do I have a graph over here on the right hand side of my board if I'm not graphing any lines? We're going to use that for the second example. And for that second example, we want to write the equation of a line, two lines, a parallel and perpendicular one. We want equations of line passing through the point 2, -5, and we want equations that are parallel and perpendicular to the given equation. Now this equation of x minus 4 equals 0, it looks like it's simpler than 4x minus 2y is equal to 3, and arguably it is, but that simplicity that we have in our second example actually causes a lot of questions with students when they're haven't seen algebra for a long time, or where they're just learning about writing equations of lines for the first time. I'm going to isolate, we've already finished the first example, I'm going to isolate this variable of x by undoing the subtraction of 4 on the left-hand side by adding both sides by 4. And we have the equation of x is equal to 4. Well, now wait a minute. In our first example, we converted 4x minus 2y is equal to 3 into slope-intercept form so that we could get that y alone, look at the coefficient in front of the x, and identify the slope. Well, here we have x is equal to 4. There is not a variable of x and y in this equation. There is not a relationship with slope in the y-intercept. There's not a relationship of, basically every unique value of x yielding an answer of a different unique value of y. We don't have that here with this equation of x minus 4. This is the equation of a line, and all the coordinates that are on this line just have to have a x coordinate of 4. There's no relationship between the variable or the values of x and the values of y. So what does the equation of x equal 4 look like? Well, I just need to list off a bunch of coordinates that have an x value of 4, because if this is the equation of a line and it only has the variable of x in it, all you need to do is have a collection of points whose x value is 4. So we have 4 comma 1, 4 comma negative 3, and 4 comma 0, and arguably lines are made up of an infinite number of points. I'm only using 3, but the slope of lines are constant. That is the equation, or not equation, that is a graph of this equation x equals 4. And vertical lines are always going to be in the form of x equals some kind of number, and they're always going to have a slope which is undefined, or your teacher may say it does not exist. If I visualize the slope between this point of 4, negative 3 and this point of 4, 1, there is a rise of 1, 2, 3, 4, and a run of, a horizontal movement. There is no horizontal movement. It's equal to 0. That's just an arithmetic example of why the slope of vertical lines are undefined. And if you don't have a slope, how are you going to work with the point slope form of a line? Which again is y minus y sub 1 is equal to m times x minus x sub 1. How can we do this second example the same way when point slope form or standard form, arguably a little bit more complex with that, or even your slope intercept form y equals mx plus b, those are asking for the slope of the line, and they're actually asking for both x and y values. We don't have a slope to put in here because the given line is undefined, so we have to think about example 2 quite a bit differently. It can be less work, but it is a different, completely different thinking process. You need to think about it graphically, basically. So we need the equation of two lines that start off and they go through the coordinate of 2, negative 5. Well, where is 2, negative 5? 2, negative 5 from the origin is move right 2 and go down 5. So right 2 and 1, 2, 3, 4, 5. What does a line going through that point look like that is parallel to the given line of x equals 4? Well, it is also going to be a vertical line. And what is the equation of a vertical line? Equations of vertical lines will be in the form of x equals some number, and that vertical line has to pass through this point, this coordinate having an x value of 2. The parallel line will be the equation x is equal to 2. And what does a perpendicular line look like? Well, let's see, what color have I not used yet? Perpendicular to vertical is horizontal. I have to draw a horizontal line if I want to intersect this in red, this vertical line in orange. If that's going to intersect at 90 degrees, it needs to be horizontal. Horizontal lines have a slope of 0. In the form of the equation, if you move horizontally, the values of x are changing, but if you don't move vertically at all, just horizontally, the values of y are constant. So the equation of a horizontal line is going to be in the form of y is equal to some number. And the y coordinate of the point that this line has to pass through is equal to 5, and that is the equation of our perpendicular line. Y is equal to, I think I just said positive 5, but y is equal to negative 5. And that is the end of my last example. I'm Mr. True. Bam! Go to your homework.